Hello and welcome to this short presentation on EngineRoom software. My name's Chris Dunham and I'm the Managing Director of Carbon Descent. We've been going for about 14 years and hopefully, as the name suggests, you realise we are a company about reducing carbon emissions. EngineRoom is just one product out of 4 software products that we sell. We provide both software and consultancy services. A bit of background about EngineRoom. It was developed by us through a knowledge transfer partnership with London South Bank University. We used it over a number of years in-house to model CHP ourselves before deciding to offer it out onto the open market as a commercial software product. Its main advantages are that it's very quick to get to an answer on the optimal size of CHP, and its ease of use is also an advantage. But it retains a robustness and flexibility in entering data, as I hope you'll see when I show it to you in a moment. The initial cost is £2,500 for up to 3 users. Then there's an ongoing £1,000 annual license fee which covers support and updates and upgrades. Right, I'm now going to switch to showing you EngineRoom itself. And here you can see there are 5 steps that you need to go through to get to an answer on the most suitable size of CHP and whether your scheme is viable at all indeed. So the first step is to enter load profiles, and what we're trying to get to here is a typical day in each month of the year and an hourly profiles for that day. So there are a number of different ways you can do that. The most technical option is to enter details about the building itself, U values, floor areas and so on, and allow the software to generate profiles based on that information. A slightly simpler method is to use the benchmark option, where you can select different building types and the software will use benchmark information to generate the load profiles. And another option is to enter annual fuel bill data or monthly fuel bill data, and the software will generate profiles on that basis. And lastly, you can actually paste in the values from another software that you might have generated in another software package, or indeed you might have monitoring data from the building itself that you can use to generate those profiles. So that's the first stage. The next stage is to enter energy tariffs. And EngineRoom allows you to model 2 different scenarios. One is where the owner of the CHP is also the owner of the site, so they're offsetting electricity and heat that they're paying for themselves. The other scenario is that an ESCO owns and operates the CHP and sells heat and electricity to customers on the site. So here you can set those customer prices, but either way you'll need to enter the imports and export tariffs. And you can do that for electricity. You can see here different types of tariffs: seasonal time of day, simpler, standard tariffs. And then the next stage is to select the engines that you wish to conduct the modeling for. And here you can see I've already selected some engines. EngineRoom comes preloaded with a database of CHP engines and information about their part load efficiency and costs and so on. You can go in and edit that and add to it should you wish to. Down here we have different control options. Conventionally people tend to choose either heat led or power led. You can do that in EngineRoom. And here you can specify the run times for the engine, or you can allow the software to decide that for you. The next stage is to enter financial information such as the project life, discount rate, inflation. Here you can set levies and any subsidies that the scheme might attract. Down here you can set tax rates, depreciation and so on. And here you can also set the cost of any financing. And if you wish to go into, if you have this information, you can enter much more detailed capital cost information. As you can see here, you can do that in 2 ways. You can either set it as a percentage of the CHP cost or as a fixed cost value. The final stage is to set the emission factors that you wish to use for the analysis. So here you can see CO2 emission factors, and here we have NOx, SOx, carbon monoxide and particulates that you can use should you wish to do that level of environmental modeling. And so it just remains now to press calculate to get our answers. So here you can see a comparison of the engines that we selected, different engine sizes, and this is net present value. So it looks like the 229 kilowatt engine comes out the best in terms of net present value in this case, and again in terms of internal rate of return. But in CO2 savings you might wish to choose a slightly larger engine. So at this stage we might now wish to go back and model one of those engines in more detail. So let's have a look at our 229 kilowatt electrical engine. And here you can see what's actually going on for each of the months of the year. And for a typical day you can see the operation of the CHP against the demands, as you can flick through each month and so on. Here you can look in much more detail at the discounted cash flow analysis, and you can see all the assumptions that are being made. Here we have incomes, operational costs, the cash flow, any financing costs, depreciation, tax, before we get down to our discounted cash flow, which then gives us our MPV and internal rate of return results that we saw before. So that, in a nutshell, is EngineRoom. Thank you very much indeed for listening.